Hey there, physics students. So today we have another lab activity that's going to help us to work with our significant figures that we've been working on. It's called the Circumference to Diameter Ratio Lab. It's going to help us to attain precision in measurements. What we're going to do is we are going to take some circles and we're going to measure their circumference and we're going to measure their diameter, and then we're going to make a graph of circumference versus diameter, and we're going to see what the slope of the line on the graph is. Maybe some of you already know what it's going to be. It's a pretty special number, but if we get the correct number of significant digits, we work well with our significant digits, then we should see a very familiar number for the slope. So let's go ahead and let's find some circles, and we'll measure their circumference, we'll measure their diameter, and then we'll make ourselves a fun little graph. So let's go ahead and do that. Alright, I have a number of different circles here. It doesn't matter exactly how many we use. I have a roll of masking tape, which is a nice circle. I have a weight here, which the bottom of it is a nice circle. I have a roll of copper wire, which the bottom of it's a nice circle there. And then I've got a few different washers of different sizes. I've got a big washer, a medium washer, and a little washer. It doesn't matter exactly how many we use. We just want to have a good number, 5, 6, 7, something good like that. Okay, what I'm going to do is I am going to measure the circle's diameter, and I can easily do that with just my ruler. I can lay it down here. So let me call this my first circle. I'm going to lay it down here and try to line it up at its widest point there. And I'm sorry you can't see this on the camera. The diameter of this circle looks to be 11.55 centimeters. So I'm going to record my diameter as 11.55 centimeters. Okay. And then how am I going to measure its circumference? What I'm going to do is I'm going to take a piece of string and I'm going to wrap it around. Wrap it around my circle. Handle my string. There we go. Wrap it around. I'm going to try to put it in a place that best describes my circumference. The tape is sticky and the string keeps getting stuck. Okay. It's gonna pull it tight. And then I'm gonna take my pen and I'm gonna mark on the string where it overlaps with itself. And mark on my tape quite a bit. And then all I have to do is measure the distance between those two marks on the string. So one of them I'm going to line up with 0, the other mark here it is. And the circumference there looks to be we'll call that 35.85 centimeters. 35.85 centimeters. Okay, now let's look at another circle. So we've done our tape. Maybe let's do the wire next here. Okay, so I'm going to put the bottom of it here. I'm going to try to line it up so that I go right through the middle. And this looks really close to 5.5. So since it's so close, let's say it's 5.50 is the diameter. And then let's see about the circumference. I'll wrap my string around it as best I can. tough to wrap around. Okay, that's pretty good. It's pretty close. Okay, and then we'll measure the distance between the marks on there. And I get this 17.9. It's real close to 17.9. Let's say 17.90. So we've done that one. Let us try, let's do the washers here. Here's the big washer. Let's see, its diameter is, let me see, it's 5 points, almost right on the 5.7. We'll call that 5.70. Oh, it's pretty close to what the wire was. Yeah, it's pretty close. Just a little bit bigger. Okay. So hopefully we see the circumference is pretty close. I have a lot of marks on my string and I don't want to confuse them. Okay, let's see. Got 18 points. Got 18.2. So 18.25. Alright, so that was the big washer. Now let's do the medium washer. There in our diameter, right, we get about 3.8. We'll say 3.80 centimeters. Let's find its circumference here. Choose circles a little more judiciously, then it might be easier to wrap the string around them. This is pretty good here. Alright, and circumference there, we got 12.35. Okay, that's the medium washer. Let's take a look at the small washer. That's right about 2.5. We'll say 2.50 centimeters. And then its circumference. .35 centimeters. And I've got one more circle here. I've got the bottom of the weight. So let's see what we get here. Right about 5.4. Say 5.40 for the diameter. And then for the circumference, Got so many marks on here, I don't want to confuse them all. That's right about 17.2. We'll say 17.20 centimeters. Okay, so I've measured the circumference and the diameter of all of my circles. Let's go make a graph. Okay, so let's go ahead and make a graph of the data we just collected. I'm going to use this program that's called Graphical Analysis, made by a company called Vernier. This should be easily accessible to you. If you go to your app store, you should be able to search for Vernier Graphical Analysis. It should come up fairly easily. It should be accessible to you, and it should be free. So if you want to use this program, you're welcome to go and find it on the Chrome store. If you want to use a different program, you're welcome to do that. If you want to make a graph by hand, whatever you like. Okay, now this particular program is designed to actually collect data using sensors. We collected our data manually by hand, so I'm not going to choose that option. I'm going to come down here to manual entry, and I'm going to click on that. And when I click on that, you can see I get a nice little chart here. I can enter my data in there. So what we're going to do is we're going to make a graph of circumference versus diameter. Now when you name a graph like that, something versus something, the first thing goes on the y-axis. So I'm going to come here to the y-axis and I'm going to change this. I'm going to title this circumference. We measured it in centimeters. Now you can see when I put that on there, it changes the axis of my graph. It's now titled circumference. I'm going to do that same thing for the x-axis. On here we're going to put the diameter, which we measured in centimeters. That appears on there. And then if I come down here to this little graph and I can choose edit graph options, it'll allow me to put a title for a graph. And a great title for a graph is y-axis versus x-axis. So I'm going to put circumference versus diameter. Let me get that creative. That tells us exactly what it is a very good title. And I can't spell. Circumference. Okay, there we go. Clearly I can't spell. And my title appears up there at the top. Okay, now we'll enter the data that we collected. So our first circle had a diameter of 11.55 centimeters and a circumference of 35.85 centimeters. We had a circle that was 5.50 in diameter and 17.90 in circumference. As you can see, as we enter the data, the points appear on the graph. 18.25. As we add more of them will appear. 80, 12.35, and 2.50, 8.35. Common mistake is getting your axes backwards. A lot of times I'll see students put what goes on the y-axis on the x-axis and vice versa, and this will cause your graph to be kind of messed up. Another thing we can consider with some things that you measure, you might have a point where you might have a point that you didn't actually measure, that you can kind of conceptually understand, right? Let's think about if we had a circle with a diameter of 0. Could we say what its circumference would be? Well, it would be infinitely small, right? So its circumference would be 0. So oftentimes 0, 0 is a point that we can add to our data. You just gotta kind of think about it and think whether it makes sense to do so, right? Here it does. So now I have all my points on my graph, and if you take a look at it, it looks like it lines up pretty well in a nice straight line. So what we want to do is we want to find the slope of this line. And that's very easy. We'll come down here and we will apply curve fit. You want to think about what kind of curve you expect it to be. I expect this to be a straight line, so I'm going to pick linear, and then it'll give me some information about that line. Okay. Now I expect the slope of this line to be pi, because that's the ratio of the circumference to the diameter of the circle, pi, 3.14. What you can see in the box is I got 3.09. To, the smallest number of significant figures I had in my data was 3. So I'm going to trust this to 3 significant figures and round that to 3.09. Now, it's fairly close to pi. You can tell it's a circle. It should be pi, but it's a little bit off. Maybe you can do better. Maybe you can get closer to pi. If you could get very close to pi there, then you've done a very good job of measuring accurately. I could have measured a little bit more accurately, but maybe you did better than me. Okay, so after you've made your graph and you've found your slope and you can see how close you get to pi, there are some questions for you to answer on the handout after the analysis portion. So you should go ahead and you should answer those questions before you turn that in. So that was the circumference to diameter ratio lab, an opportunity for us to practice our significant figures. Hopefully that helps us to be able to attend to precision in measurement. So until next time, take it easy.